Hey, it's Mrs. Weefy, and we're starting Unit 6 on gases, liquids, and solids. So let's first start talking about intermolecular forces. And you might wonder why we're going to focus on intermolecular forces when we've already talked about this in the unit on bonding. Well, the reason for that is that intermolecular forces influence the properties of the physical states of matter, the solids, the liquids, and the gases. Before we get into intermolecular forces, let's review a little bit about electronegativity and bond polarity. When two atoms interact to form a bond, we have to consider the electronegativities, because the electronegativity affects the manner in which atoms interact or bond. So the electronegativity of the atoms in a bond determines the polarity of the bond, and the polarity of the bond determines what kind of intermolecular force takes place between molecules. The electronegativity, by definition, is the tendency of atoms to attract electrons that are in the bonds. So let's take a look at the periodic trend. So if we go across the period, we see that the electronegativity is going to increase. And why is that? Well, we had discussed before in the unit on the periodic table that as you go across the period, the nuclear charge increases. And that is, we have more protons are being added to each one of those elements as we go across the period. And so the charge of the nucleus becomes stronger and you have a stronger attraction for the electrons. So the electronegativity increases. As we go down a group, however, we see that the electronegativity is going to decrease. And why is that? Because we're adding on energy levels, increasing the distance and a weaker attraction between the nucleus and the electron. So we have a decrease in that electronegativity. What is an ionic bond? Well, we know that ionic bond is the transfer of electrons, and a covalent bond is the sharing of electrons, in which we have two types. We have nonpolar, which is the equal sharing of electrons, and polar, the unequal sharing of electrons. And these all play an important role in intermolecular forces. Now we have degrees of bond polarity, and those degrees of bond polarity are that we can have bonds that are nonpolar, slightly polar, or bonds that are very polar. We determine those by the differences in electronegativity. And again, this is just review for us. So if we have a difference in the electronegativity between two bonding atoms of 0 to 0.4, we have a nonpolar covalent bond. Between 0.4 and 1.7 is polar covalent, and between 1.7 and 4.0 is ionic bond. So covalent bonds can be nonpolar or polar. Ionic bonds are the most polar because you have complete transfer of electrons. But in general, if we look at the location of where those elements are on the periodic table, the further apart they are, the more polar the bond will be between them. So molecules, on the other hand, can also be polar or nonpolar. A molecule is polar because you have a partial positive and a partial negative charge on either side of the molecule, and that is because of the unequal distribution of electrons. And so this diagram shows us that unequal distribution of charge, and we can see that better in a water molecule. So in a water molecule, we have the oxygen is higher in electronegativity, so it has a stronger desire for those electrons. It's going to pull those electrons closer to it, giving it a partial negative charge, where the hydrogen atoms will have a partial positive charge. Now, molecules, as I said, can also be nonpolar, and a molecule is nonpolar because we have an equal distribution of the positive and negative charges throughout the molecule, as we see in this diagram here. Now, an example of this would be carbon dioxide. Now, the interesting thing about carbon dioxide, however, is that carbon, the bond between carbon and oxygen is actually polar. But when you have the two ligands, the two oxygen molecules bonded to the center atom, the carbon, those partial negative charges kind of negate one another, and you have this equal distribution of the positive and negative charge within the molecule itself, making it nonpolar. So let me leave you with this. Be happy, have fun, and just dance. This is me, Mrs. Weethy. Until the next video lesson, so long for now.